Welcome to our 10th episode of the Water Talks podcast, where water treatment, practice, policy, and innovation receive the focus that they deserve. I am your host, Els Vanbeckevoort, and I am very happy to be joined by my co host, Scott Bowron. Good morning, Scott.
Good morning, Els. So good to see you again.
Nice to
And
see you as well.
I'm so excited for today. This is going to be a great chat with Dr. Michael Beach. Uh, really, today we're so excited to introduce the topic of waterborne disease prevention with our esteemed guest, Dr. Michael Beach, former Associate Director for Healthy Water at the U.S. Center for Disease Control and Prevention. Welcome to the show, Dr. Beach.
Thanks so much. It's great to be here. Excuse the mess in the back there.
It's
I'm
all good.
retired now, so it's okay.
It's a place where
Yeah.
work is done. That's all good. It's all good. For our listeners, Dr. Beach has a Ph.D. in biochemistry from Purdue University and a long, lustrous career researching waterborne diseases in potable and leisure water applications. So, yeah, great to have you, Michael.
Thanks.
What a background, and we're going to let you introduce yourself, Dr. Beach. I'm proud to say I've known you for so many years through the Model Aquatic Health Code and the World Aquatic Health Conference and all those moments when we've had the chance to connect and had some chats over the years. So I wonder if, just to start us out, could you give us a bit of a background? Where did you start? How did you get to today?
Sure. Thanks. And good to see you again, Scott. Like you said, it's been a long time actually that we've worked together on things, and good to meet you, Els, as well. Um, I guess, I first of all will say, since you're in Canada, I'm actually Canadian. So born in the Toronto suburbs, grew up there for until like age 12 or something. Then we moved to the US. But I always had a love for biology, chemistry, kind of the technical side of things. And so that's the direction that I took. Biology undergraduate degree. I went to Purdue and got my PhD there, and then kind of started looking at viral systems and bacterial systems and that sort of thing. And I went to work for the U.S. Centers for Disease Control here in Atlanta. I still live in Atlanta, and in 1989. I worked in the lab there, and it was interesting, but there were all these outbreaks occurring that I was working with these epidemiologists as they were doing these outbreak investigations. And after a number of years, I said, I actually want to do that. I don't want to just be in the lab anymore. And so I switched, kind of did a transition through this kind of disease detectives fellowship to start doing outbreaks and other things. I moved to the parasitology group and started doing that in 1995. And then, 34 years, basically, that's where my water background came from. My first outbreak, actually, the day I showed up, was the largest waterborne outbreak of cryptosporidium at a U.S. water park in the country. So that was my introduction. And I kind of came out of that saying, we have got to do something about treated swimming pools and spas. There's things happening there that we need to take care of to move forward in that. But and then 34 years of doing that and a number of other things, and I retired after the COVID pandemic, and I guess now I'm really still into water. Our family is a water related thing. What can you say about somebody with the last name Beach? Always going to the beach, always to the water, backpacking, into the rivers and streams, kayaking, canoeing. Those are the sorts of things we do. I'll be going up to actually your beautiful Nahanni National Park up by the Yukon Northwest Territory border in June to canoe down that river. And so, and I was at again, Northwest Territories doing the Keel River last year. And so I just love water, and I believe that we can make these sorts of activities healthy and safe for everyone.
Michael, that's funny because as I was, looking at your profile, and I found that there's another gentleman named Michael Beach who was actually in a movie called Aquaman.
Yes, right,
I was like,
exactly.
oh, wow. Maybe, you're also perhaps doubling as an actor in the background, the movie about water.
Yes, exactly.
No,
You took your MO there.
yeah, for sure. So maybe then, for our listeners, tell us a little bit more about waterborne diseases. Like, what are they? How could they be
Yeah.
classified? Like for the lay person. What are we
Right. And
talking
so
about?
just think about, when we talk about waterborne disease, we're talking about diseases that are spread. How do you get them? You can drink it, you can have contact with it, you can inhale aerosols. If you spray water into very small droplets, those can actually be inhaled. All of those can transmit disease depending on what the water quality is. And so that's kind of thinking about the route of spread, but
Right.
also we like to classify because of our tracking data, what's related to drinking water, what's related to recreational water, both treated, the pools and spas and that, and untreated, your rivers, lakes, and so on.
Right.
And then the non-drinking, non-recreational. There's industrial uses, cooling systems, agricultural use. All of that can spread illness, and so we tend to collect data to tell us, what's going on as far as distribution. We make estimates around that, as far as to give us an idea about what's the magnitude of the burden of disease. That's for policymakers, that's very critical for them to know, is this worth thinking about? Is this something that we should be investing more? And as infrastructure change, turn of the 1900s, the US competed. They wanted to be like Europe, and they
Right.
basically, let's get chlorination and filtration in place in cities across the US. Get rid of cholera, typhoid, which were rampant across the country.
Right.
They're waterborne diseases that can be spread by drinking water. And so as cities did that across the US, you saw disease plummet in these cities. And having a water treatment plant was the symbol of success, whether it was Baltimore or Chicago. That if you go to, for instance, the Baltimore, Pennsylvania, and look at the water treatment facilities, they look like Greek temples, because
Right.
that says we made it. We're as good as the Europeans who had started this earlier.
Right.
And so we saw those common diseases disappear. But as the world has developed, what we've seen is we've come up with other issues, which is, first of all, we put those pipes in to do that, long time ago, and we don't like to replace infrastructure. It's underground. Let's forget about it until everything breaks. So we
Right.
have crumbling infrastructure. We've also got 6 million miles of pipes in buildings now in the developed world, all of which, if you don't keep disinfectant levels up, how long the water sits there, you get
Yeah.
these pathogens growing in those pipes. And what do you do when you have more leisure time? You go swimming. And so this kind of developed world paradigm is different. It's a different host of diseases that are spread, but it doesn't mean they're gone. They're just they're different names, but there's still this disease occurring.
Yeah, I
Yeah.
believe that. I think that's a very good point, because we are indeed maybe spending more time in leisure facilities, and there's lots, like, not only more time but longer as well, right? So I think there's a number of different ways in which there's a potential for exposure. So perhaps maybe would it be possible to give us some visibility from your perspective? And I've looked at some of your interesting publications that you've co-authored, but what are some of the main pathogens, if you like, of concern, maybe in drinking water, and does that translate to pool water, or are we looking at unique, specific microbiology that we need to be concerned about?
Yeah, I mean, I think it's emergence of new pathogens, as well as kind of these changes I talked about in infrastructure and that sort of thing. And so, post 1980s, what really emerged kind of post HIV epidemic is this chlorine tolerant parasite called Cryptosporidium.
Right.
And that's a game changer, because
Mhm.
both drinking water and recreational water have relied on chlorination as the major barrier to spread of these diseases. And here, all of a sudden, we have a pathogen that's extremely chlorine tolerant. And so
Right.
we saw waterborne outbreaks associated with drinking water systems occurring across the US. And again, this is global too, but we collected surveillance data around the US, with the biggest one being, 800,000 people infected from the Milwaukee drinking water supply in the early 1990s. And so, But it was clear that this is equal opportunity transmission. That what you saw after that Milwaukee outbreak, where actually it was half the city were ill and probably the other half were infected. That was just the biology of the parasite. But
Right.
what you saw is everybody moved out of town because they didn't want to drink the water. They were ill, and what did they do? They went to the hotels and motels and went swimming. So we saw all of these satellite outbreaks around the drinking
Right.
water outbreak that were recreational water associated. And, this is, I mean, we could tell at that time, this is the direction things are moving. The aquatics industry has to prepare for it.
Right.
And, because again, drinking water systems are much more sophisticated and
They
better
are.
operated usually
Right.
than a swimming pool, as we well know. And,
For sure.
so when I first talked to the aquatics industry about cryptosporidium, it was coming. We'd already had recreational water outbreaks. There was a total disbelief that I was kind of making this up. That turned a tide and everything, but we've had to move with that. Other pathogens are, again, Legionella is a pathogen that lives in, that
Biofilm.
inside a pipe. That scum layer that's
Slime.
inside the pipe is a biological family of different organisms, and pathogens such as Pseudomonas and Legionella can reside in there. Under right conditions, they can amplify. And then Pseudomonas through contact and other things, or Legionella through aerosolization, can be spread. And so you have a respiratory disease and contact,
Skin potentially, right?
skin disease and everything occurring there.
And
So
all of those are horrible diseases. As I was looking at one of the papers, obviously death rates are at the top for those two, at least. I got cryptosporidium on my travels when I was working, doing business development in Europe. And I think I'd gotten to Spain and drank some contaminated water.
yeah,
And it was horrible. Like, it was
I'm
horrible.
sorry. Yeah,
I was like truly out of action for 2 weeks. It was not very pleasant, but I recovered well. But as I look at Pseudomonas, particularly for immunocompromised people, and Legionella as well, like, it has a fairly high fatality rate, right?
right, right. High fatality rate, especially for at least Legionella, older folks who smoke and that sort of thing. But it really is the driver from an economic, the healthcare costs of this are driven by these biofilm associated pathogens because they cause more severe disease.
Right.
Most of what we see transmitted, kind of the recreational, are, it's gross to talk about it, but it's diarrhea. And
Yes.
what a perfect medium. If you have diarrhea and you get in a aqueous environment and there is an incident, that can spread very readily to everybody in that pool, and everybody that pool is connected to by recirculating pipes.
Right.
And so I mean, I think that's a real issue for all of us to think about. It that's an economic driver. The other is Pseudomonas, which is this was by accident. Actually, we were doing this analysis. I just didn't realize how much it was going to be. But Pseudomonas is a huge driver from an economic standpoint because it causes otitis externa, which is outer ear infections, otherwise known as swimmer's ear.
Mm-hmm.
And so it's not the middle ear infection that little kids get. It's the outer ear, so that, if you wiggle your outer ear, you scream.
Right.
And so it's easy to track because generally people go to the emergency department. It's just too painful.
Right.
And relatively cheap to treat, antibiotic ear drops.
Right.
But there are millions of cases per year. And so it's a driver economically because cheap disease, but millions of cases says it's costing you $1 billion or so.
Right. Right.
And yeah.
No, I understand that. I guess, and I've also seen people who've contracted Pseudomonas from hot tubs on their skin, which can also be quite systemic. So not just skin, but also, illness that goes with that. Like, if you got some experience in that, have you seen that?
Yeah, I mean, we do. It's harder to track.
Yes.
It's less frequent, but Pseudomonas can cause a pneumonia, and it can cause blood infection, septicemia. And so clearly the outer ear is something we pick up a lot of because of the emergency department visits. But in hot tub rash is essentially Pseudomonas. When you go in a hot tub and later on and then you walk around your suit for a while, the next day you have a very painful rash, the shape of your swimsuit, where you've kept that contaminated water up against your skin.
Right.
And again, that's not that can occur on fabrics. We've also seen it, the tubes when you ride down the flume at the water park, can have, if they aren't cleaned properly, can have a biofilm, and you have a rash basically at where you were grabbing onto the tube. So again, pathogens are amazing at how they can exploit just about any habitat you could imagine. They're going to figure out how to get in there and do something. And so that's why we have to be diligent on all of these sorts of things: water quality, air quality, and everything in the aquatic environment.
Right.
So, Dr. Beach, talking about pools, and I'm an operations person, and we have a long ways to go in understanding. That's clearly understood. I mean, you're just so astutely understanding this. How do we make them safer? How do we, from the big picture to right down to the average pool?
It's a great question. And, pools are a complex system, and we treat them like they're not. So, the first, I'm just thinking about, we see instances, for instance, the hotel motel pool. That's not even a full-time person usually. It's usually somebody working in the kitchen that's been assigned this task, an onerous task of going out and testing for chlorine or whatever. And that's just, we just need to put an end to that long-term to really protect the health and safety of the users and everything. I'll get into this, Scott, just real briefly, but part of all of these outbreak investigations and what I said to kind of leadership is, this is coming. It's already here. Cryptosporidium is the tip of the spear. But what we see is, the pathogens you wouldn't expect, the Shigellas, the toxigenic E. coli's, Campylobacter, all the ones that we should never see that in a properly operated swimming pool. We were still having some outbreaks. Again, all of which, when you get back to it, is poor pool operation. Because if you maintain your pool appropriately, we got rid of the mass, certainly of the most of the bacterial pathogens, the diarrheal causing bacterial pathogens. So the fact that we're seeing those says we have a job to do. And so, what I said to the group is, we need to get our public health colleagues on board first and get the industry on board. And so we held a national meeting actually back in 2005. How are we going to fix these recreational water illnesses, associated illnesses? And we came, one of the main recommendations that came out of that group at that time was, everybody across the US, and I think it's Canada as well, is basically, most of the regulation is at the state and local level, provincial level or local level. And everybody's reinventing the wheel. Most of the folks there don't have the knowledge base to create a code. Codes are very complex on how to operate. What they said is, please save us from ourselves. Come up with some guidance, model guidance, which is the Model Aquatic Health Code, that lays out what we should do, and then we'll take that and adapt it, how we need to use it and how we were going to move forward, and make sure that it's kept current, because we have codes in the US that are 50 years old. They couldn't possibly keep up with the technology. And so that was the recommendation, was make a code, a model code that we can adopt in part or whole, or however you want to do it. Explain why you're saying it. We have an annex that explains the data behind it, and renew it periodically so it keeps up. The aquatics industry is driving things, the latest, newest things. Surf venues and lagoons being the latest, that are kind of being built now. And so, and this is where I first started working with Scott. We created a national network of subcommittees to work on different facets of this across the US. We determined, what I wanted to see is that we worked with the industry and public health and academia as a partnership to build this. It wasn't just about government coming in with a sledgehammer. It's like, let's do this in a feasible, implementable fashion, evolution versus revolution, so that we can work with the industry to move things forward. And so that went from many years, about 7 years of those subcommittees, getting people to agree on things. And some of the issues we agreed for the first time in the US on how to put things on paper. And then the first edition came out in 2014. Actually, the 5th edition, we just had our every 3 years. Now it's changed to 3 years. The conference for the Council for Model Aquatic Health Code is a nonprofit that has a meeting every 3 years, brings together memberships, and they talk about how we need to improve and change and all that. They just had the meeting in February. The new edition just went to see, this is owned by Centers for Disease Control, by the way.
Right.
That's really critical. It's a public health document owned by CDC, and it's updated by this consortia of public health industry stakeholders that are in there. And so the 5th edition should be out, this year and next year.
There is so much a wealth of information in this document, and we refer to it frequently when we're meeting with clients. I know Scott does as well, as we try to help people to progress to a more optimal state. I would say that maybe just to go back to Scott's original question, what should we do to make the pool safer? There's some very specific things that it talks about in the MAC that I think are very useful. I really like their focus on filtration and teaching people how to actually adopt proper filtration. Because often there is such a heavy reliance, and not to say that chlorine is not a great technology. It's kept us safe for many, many years, but it has its own limitations, its drawbacks, and its challenges. And I was so encouraged to see that there's a holistic approach, just like we would have in municipal drinking water applications, where you have a multi-barrier system, where you have multiple barriers that help to make sure that if something breaks down, there's something else to have your back, right? And so maybe could you speak to that a little bit, Michael? Because I think that's a great way to
That's how we've seen this long term, is that we want to professionalize aquatics. It needs to be more professional, just like the drinking water industry is. People's health is at stake.
Exactly.
You're not talking about 3 people in a pool. A typical water park has thousands of attendees. And so I think the first thing is, you look at filtration in swimming pools, it's mostly rapid sand in a can. What do you think that's doing? It's able to remove chunks, but not much else. It's really not improving water quality much. Maybe keeping turbidity down a little bit, but it's not from a pathogen's transmission. And so what we've been trying to do in the MAC is incrementally improve how filtration is done. And so bed depth, what kind of material you have. Should charcoal be added?
Speed through the filter.
The speed through the filter. I mean, think of it, a filter. The faster you push it through, the less filtration you get. Filtration is really dependent on a complex thing, not just these particles. There's also this, is a German word, Schmutzstecke, this slime layer on top of it's the microbiological part on top. This is all improves filtration. And what we want to do is move aquatics towards improving that. And so we're doing that incrementally. Chlorination, the days of hand feeding are over, that you need to have a controller that's monitoring and maintaining chlorine levels so that you have, electronics are great. It doesn't mean you don't have to check them from a human standpoint, because we see a lot of errors where things go wrong and nobody bothers ever checking a system that's broken. Many outbreaks, that's actually what's happened, is operators took for granted, I've got electronics, I don't need to pay attention, and that just doesn't work. So chlorine levels being maintained on a regular basis, especially with Cryptosporidium coming in as a kind of an emerging pathogen, we need something in addition to chlorine. This happened with drinking water systems across the US, many of them which were totally reliant on chlorination. New York City, and that now have, which basically now they've implemented massive ultraviolet light systems that in Cryptosporidium is exquisitely sensitive to UV light. And so having a combination of UV light, chlorination, improved filtration, I think is really critical there, so that that we kind of catch everything, and risk assessment is part of this as well. Is that where do you have the highest risk from a diarrheal incident standpoint? Probably not in the where the 30-year-olds are swimming. Ground zero is actually where the diaper age kids are. The under 5s are more likely to be infected with these pathogens, more likely to be incontinent. And we have parents that just don't want to say no to their children when they want to go to a bathing. So, and these pools have much lower volumes of water. So when you talk about drinking pool water, people do, especially kids. And how do we educate the consumer about what's acceptable and what's not acceptable from a shared aqueous environment?
Right.
If one child contaminates that water, it puts everybody at risk. And this is actually in pools, but it's also when you go to the lake, because where are all the little kids playing? They're in that shallow, poorly circulated area, and that's what we see in outbreaks there too. And so I think those technologies are really critical that we improve them over time. And clearly that has to do, and I know we'll probably talk about it later, disinfection byproducts
Yeah,
and air
yeah.
quality and everything as
Right.
well.
All of those things are connected to that. But maybe just to focus in, if we can, a little bit on, this multi-barrier principle. So,
Yep.
the UV, of course, is excellent with crypto, but I also understand, if you have flocculation, right? So this is one of the
Yeah.
things I wanted to talk about. It's right in your model aquatic health code,
Yes.
using, I don't know how many pools that we visited where, flocculants are dumped into the pool and everything sinks to the bottom. And it's like, okay, it makes no sense. It needs to happen before your filter. And it
Right.
verbatim says so in the MAC. It tells people exactly how to do that. And I'm thinking, okay, this is such an important tool. If you're going to have filtration, make sure the speed is slow enough. We talk about 20 meters per hour maximum through the filter, preferably lower than that. So you have to design your system so you get enough turnovers, because that's also in the MAC.
And so, yes, you have to invest in a better system.
In a better
to actually get better quality.
Because you get a 3-log removal for crypto, with 7 turnovers, but not at a speed going through the filter at 30 meters an hour.
Right.
So those are all considerations, right? So I think, go ahead.
Sorry, I was going to say flocculation. I agree. This is clearly, that's based on drinking water, has used it for 100 and some years.
Right.
I think it's a work in progress for the MAC to move people in that direction. I don't see how we can improve filtration the way we need to unless it is incorporated.
Yes.
What we need is, again, it will require a higher level of training for people, because what they don't, it's that old adage, if I put a little bit in, much more is better. And that's not always the case. There are sweet spots for how much of these flocculants, clarifiers, coagulants, however it is termed on the bottle, of how they're used. And so we want a better understanding of how to give guidance on that and get people to stick with that, so that, again, if you bring these particles together so they're bigger, they're removed by filtration.
Exactly.
That's why they flocculate, and they have clarifier ponds in drinking water that allow that to settle out, so that and again, pathogens tend to aggregate around particles in that. So you tend to preferentially bring them out. That doesn't fix the biofilm ones per se, but certainly the ones we're talking about here from a cryptosporidium standpoint.
And backwashing perhaps is another, another aspect that's again highlighted in the MAC. I was delighted to see that they're talking about air-assisted backwash, because your filter is only as good as the backwash that you get. Having a little bit of bed expansion, maybe reducing the amount of water you need, but certainly, seeing a much improved backwash, like that's another critical piece of the picture, right? If we're talking about
and on top of that, that understanding about this, like Schmidt-Stecker layer and so on, that a filter, as with drinking water, has to be primed.
Right.
And so you need to be able to backwash your filter, get some loft, bring out the pathogens. You shunt that to waste because it's concentrated for pathogens probably.
Right.
But then you need to run it before you put it back in operation, run it for some period of time so you can reestablish that layer and get things back to where they were, and then turn on the full system.
Right.
Exactly. And so this is actually one of the issues with the Milwaukee drinking water outbreak, was that they backwashed a filter and then they were using it essentially immediately. And then basically pore size, all of a sudden you're pushing, and they didn't get rid of the backwash the same way. And so you were putting pathogens back into the system. And again, for the US, that resulted in new EPA regulations about how to backwash drinking water systems. It's all, again, we learn from mistakes. Outbreaks are mistakes of some sort. But yeah, no, those are all great points.
Yeah.
Michael Beach, sorry, Michael, I want to call you Dr. Beach.
No, I don't like that. Yeah.
Well, we're kind of, I'm an operator. I do CPO training. How necessary is this pool operator training? And And then
And
the guest.
I did not plant this
Yes.
question. I did not plant this, but oh my gosh, come on. This is such a complex system. If you, as you've heard from what we're discussing here, filtration, flocculation, chlorination, chemical storage, all of those sorts of things, this needs to be taken seriously. And that means training the people who do this. And where it's as you expect, the highest level of training is in the biggest places like the water parks. They get a lot of training. And when I work with those folks, I can certainly tell a difference from when you're at the other end of the spectrum, where people really don't know much of anything. They know how to do the test for chlorine. They don't really know how to interpret it, but they don't necessarily know why they're doing it. They've just been told. And so I think it's absolutely critical. What we've seen in data that we've collected is that, when you look at places that require training versus those that don't, you see fewer violations that can potentially lead to these incidents. That education counts. And why we're questioning this still in 2024, I'm not sure, but it is critical. And where the MAHC is pushing forward is, first of all, it recommends requiring training. It actually recommends, and here are the topics that must, training could be 20 minutes. That actually is not worth much. But here are the topics that must be covered within that training to ensure that that operator knows what's going on, and that there are places for them to go and get back up and that sort of thing. And I think that's really, if I were going to, that was one of the first things we did. Absolutely recommend that this must be required, no exceptions. And yes, we need to keep costs down and all those sorts of things. We know about turnover of staff and everything, but it's critical that everyone is trained. Otherwise, you open yourself up to huge risk of events, whether that's, and actually, it's not just about microbiology. Aquatics is about safety. The guards, the operators, all of them need to be well trained to keep the health and safety aspects of an aquatic venue. Let's face it, aquatics is the most fun thing around. It's the best. Millions and millions. It's a community service. It's a huge industry. It's about fun. And so the least you want to, you don't want to come home with diarrhea. And what can I say? That we can, these are preventable.
Right. And Michael, like talking, a little bit further, talking about not just microbiology, you said it's not just microbiology. There are other considerations, right? So I know I've been to many pool envelopes where, I get a sore throat, my eyes start to water. I just feel unwell if I'm there for more than 20 minutes, half an hour, just because the air quality is poor. Clearly, that's a process that's not optimal. So do you think toxicology is another important parameter as you're looking at risk in a pool?
I do think that, again, we learn a lot from drinking water. We've known for a very long time that chlorine is a non-specific chemical oxidizer. It binds to anything. And so some of it being pathogens, you want to kill them for sure.
Sure.
But it also binds to all the other things that come off of, frankly, it's all the waste, feces, urine, sweat, all the residue that comes off human bodies. And aquatics without swimmers isn't useful. And so we're going to have to contend with all of this. And so we know when they bind, they make these disinfection byproducts from, they're organic carbon containing ones, but they're also nitrogen containing ones. Yes. So when you go into that indoor pool, and I think people got used to, oh, my eyes sting and I'm coughing and all that, that means they're really doing a good job on this pool. It's the exact opposite. That when you feel that, that's nitrogenous waste, mostly from urine, urea, sweat, and everything binding with the chlorine, and it evaporates. It's volatile. It goes into the area, and those chemicals, those byproducts of chlorination, are what sting your eyes, make them red, and everything like that in an indoor setting. And indoor, they're produced everywhere, but indoor they accumulate. And so, part of what we've done there is think about to me, that's unacceptable that you're breathing all those chemicals. And there are other products in the water that we don't want in the water either. But
Right.
the air quality is such that indoor aquatic environments need to be built with the understanding that they have good air quality. You shouldn't, you shouldn't be breathing this air. And so
Right.
improving the air filtration systems and the whole HVAC system that's pulling air out and venting and so on needs to be tuned to make sure that you don't have that accumulation. So when you go in there and and that stinging eye, say something to your operator or your manager at that pool and say, this is not adequate. My wife is very attuned to all of this. She's a competitive swimmer, still on a master's team. She only swims at pools that have good air quality because she's very sensitive to it.
Right.
And and she will say something to them saying, I'm not renewing my membership here because you just have not improved the air quality. So
Right.
this is a commercial, for me, it's a way, if you want to sell your pool because you have good air quality, you can do it. There's a lot of information to say, come on down here. That's why, in addition, just as you go into a restaurant and you read those scores inside the restaurant door, we publish them in our local paper. I can see the restaurants that have failed. We want the same thing done, and many municipalities have done this. I want them posted on the web so that before I go to a water park or a pool, I can look it up and see how are they doing from a grading or however the municipality decides to do it. But that's a way to tell people that economically this
Right.
actually makes a difference to me, because operators, one thing we found is they do change behavior if the consumers force them.
Yes.
They
Indeed.
may resist government getting involved, but consumers absolutely make them think about how they do things.
Yeah.
Right. And
Go ahead,
we
Scott.
we actually have that here in Ontario now, Michael, where your pool inspections are documented and you're supposed to post them at the front door, like restaurants do.
Yeah.
It is based off our public health code, which still has a long way to go. Which our whole discussion today is around, minimum standards for
We all
wastewater.
do. Yeah.
Right.
Yeah.
For
So
sure.
that is a step forward, though.
And
And
just so you know, in the US, it's similar, I think, in Canada, but there is no federal oversight of treated venues, only the untreated waters. That's EPA, Environmental
Right.
Protection Agency. It's all at the stake, and at the state level, many cases, it's at the county level. And
Yes.
so that's why the MAC was put out. CDC doesn't regulate things. We
No.
advise. And so
Guidance.
it's
Yeah.
advisement guidance document to help people
Yeah.
not have to kind of relearn all of this or learn it for the first time.
That makes sense. And maybe, one of the things that we see frequently, and Scott, and ourselves as well, we try and educate people around this, but there is a lack of understanding of the true chemistry within a water, within a water basin, within a pool envelope. And that's a real challenge, because what I see in the Model Aquatic Health Code, what I see in EPA documents, even in CDC documents, and in the drinking water world, it's common practice that you need to have good standardized tests for monitoring chlorine speciation, for monitoring pH. So we visit many clients who, they have an aha moment. We bring a properly calibrated 2-point calibration pH meter that has a millivolt signal with a standard 4 and a standard 7. And we show them what their actual pH is, and they have no idea, because their actual pH is significantly lower or higher than what they think it is, right? So how do you even begin to operate a system if your measurements are off? And
Right.
that's, the same with chlorine. Often we still use semi-quantitative estimates with, like just a color,
Yeah.
subjective color evaluation to say, we were at a conference last October, I guess, Scott, it was. And, we had a workshop on mastering measurements. We took some sample from the hotel we ran the conference in, and we found that, everybody was using their color metric, or it's not even a color metric, but their test kit, and saying, oh, this is pH 7, and somebody was 7.1, and the actual pH was 6.4.
Yeah.
And that's a real problem from my perspective. I don't know how you see that, Michael, but you have to start with the most basic principles. But if you actually get that validated, corrected within your process, we've seen it make a significant impact on general water quality, water chemistry, and even your air quality. So
Yes.
do you have any thoughts on that?
I mean, you're absolutely on target, which is we have wonderful technology out there. Why on earth wouldn't we use it?
Right.
The reason is economic.
Right.
And so it's getting people to understand that this investment for electronically measuring pH, chlorine levels, and so on, and monitoring it over time actually helps you save money in many cases.
Lots.
But it also helps you avoid having these other types of incidents.
Right.
And so we're driving people to automation with human oversight.
Right.
So, I think it's critical that we do that. I mean, people used to add the chemicals by hand.
Right.
Again, that so we have to have feeders, controllers. Those are all exquisitely good equipment that we can install and monitor on a regular basis. But that's the future of aquatics. We just can't have it, we can't have it done the other way. It doesn't work like you say. And I mean, you start to get down in the low sixes. It's again, from a chemical standpoint, it's not the greatest from the disinfection byproduct, but actually that's when you start to erode the appetite on your teeth, on the enamel in your teeth. And we've seen
Yes.
that in outbreaks where the competitive athletes being in the pool that long etched their teeth because somebody wasn't monitoring the pH. That
Wow.
is inexcusable.
For sure.
And so again, I think that automation, you're all great points, Els. I think that read the MAC because it is in there. It's best. It's works for the U.S. because we have to move the industry incrementally where technology can move with them, and that we actually get this implemented instead of ignored.
And back to the training piece, because really,
Yep.
when we build in our Canadian dollars, in our rec center, Els was in one yesterday, 75, 80, $100 million is kind of a normal. And yet
Right.
the consultant, the architect doesn't talk to the engineer who talks to the pool consultant. There's no cohesion to start at the beginning when you build these big centers and truly understand the relationship of
Right.
each one of those. And,
It's-
building new and now
Right.
existing is
And
another problem.
that's why we really are looking at people requiring that there's a team at the front end that's thinking about this, that, basically, how should I store my chemicals? We actually don't want them in with everything else. You don't want to mix water with many of them. You want to keep that sequestered. We want how many lifeguards will I need at the pool? That needs to be known at the front end. And it will change if you put other things into the pool, but you need to be planning from a payroll standpoint for that. We need to know what are the safety features that go into this, what kind of equipment, that's the time, as you said, that's the time to actually, let's put in better filtration from day one.
It is.
Don't pull it
It's
out.
part of the
If
design.
if you
Right.
want the air handling system, especially in an indoor facility, if you don't want to be replacing a rusting bucket in 5 years, then you need to think about, again, these chemicals we talked about that go into the air. They sting your eyes and make you cough and your eyes red and everything. They do a number on metal
Corrosion.
as well.
Right.
And so that's why you see all this if you walk in a pool and you see corrosion all around the outside, all the metal pieces, their air handling system is falling apart due to corrosion, it says they haven't been handled, because when those chemicals are up and they redissolve in kind of vapor on the metal, they rust it out. And so in the long run, it's about a cost savings, but
Right.
we know that prevention, which is spent up front, is always hard to rationalize. But instead of getting the cheapest thing now and replacing it essentially over time, it's a very ineffective, it's not cost effective to do that. Don't try and fool the people that are trying to invest in this. Tell them up front, we
Right.
will save money long term on these systems if we invest now.
Right.
And it'll be cheaper in the West now, and it actually will be better for our patrons.
Yeah, it'll be better for everybody. And we see this,
Yeah.
like we have a waste survey that we do with clients that kind of identifies risk, identifies cost, identifies actually sustainability. So, what's your carbon footprint in a
Yes,
pool? And I think those are
exactly.
all important questions. We like one of the other things that I see frequently, and I don't know, I haven't read that in the MAC, but I read the whole document. I can't remember. Speaking about the way that the pool flow is designed. So whether you have floor injection or side injection, we have done, dye tests in pools where we've seen multiple dead zones, areas where there is a lack of flow, or you don't have good dispersion of your chemicals. So there's, and we've seen in the machine room, in the mechanical room, where chlorine and acid are injected like right beside each
Oh,
other.
yeah, yeah, yeah.
Like
Oh,
lots of these things where you think, okay, these are some really simple fixes. And well, although the pool design is actually an important one that has to happen in the front. So I wanted to get your perspective on both of
yeah.
those factors, because they can have a significant impact on ultimately how your process runs.
Right, and I think it's critical you think about it up front. It is in the MAC. One of the appendices has a dye
Oh,
testing
okay,
protocol,
great.
but it's you start talking about messing that up, you're talking about bringing up concrete,
Right,
and so a pool that's not well circulated from a chemical standpoint and other standpoint is just not going to be good water quality, and,
right.
and shouldn't differ. That you should have good circulation and everything. And so I think thinking about the basic construction, and that's part of this team, is how do we do that and move forward is laid out in there, because it's critical that you do these things up front if you really want to have a long-term investment, or you're going to be replacing a lot of things later. And that's what
Infrastructure.
those are the horror stories we hear is, oh my gosh, I'm basically replacing my entire air handling system, or I just opened my brand new water park and I'm gassing out my attendees with the trichloramines because the air recirculation system wasn't designed to think about it. And this, I mean, this was an investigation. Basically, the company had to redesign things and change where intakes and outflows and everything on the air all had to be redone because
Right.
the hundreds of patrons were suffering because of this, and it had just opened.
Yeah, which is
But
really terrible, right? When that happens, like you spent all this resource in getting to that place. And but I don't know what whether you see that in all of your travels and different applications, but there's a disconnect between the plumbing engineers often and the water quality people, and so the design doesn't really consider water quality, at least from my perspective. Like it should, but it doesn't, and that's where that disconnect is. And having maybe a
yeah,
bridge, a way to say, okay, if you're proactive on the front end and you design your system properly so that your deck runs away from the pool, you have good flow in your pool.
right. You think about
You
what you're cleaning the deck with and where that cleaning
right.
solution goes,
Exactly.
etc.
All of
Yeah,
those different principles, and on the water treatment side as well, having that, having real foresight in that way, like you're going to save yourself a world of hurt, right? Like
yes,
downstream.
exactly. I mean, I think you just brought, again, that's why people complain about how long the MAC is, but it's because we think it's pretty all inclusive. And so
Right.
slope of deck is critical.
Right.
Again, we've had issues where somebody was cleaning with something and the slope was towards the pool. Why would you do that?
Right.
And then you've got all these issues with patrons getting in the water afterwards. And so again, I think they seem like minutia, but boy, if you've done something wrong like that, it's a
Right.
big cost to fix these things. And so you want to be upfront with people about. That's why we've worked with multiple aquatic design firms who
Right.
do, they're known for designing these places. Some of those firms were involved in the creation of the MAC. They're super knowledgeable about pools specifically versus having just a plumber who's not really into pools or
Right.
air quality that doesn't know that. And I think what they've found is that it makes sense for them to incorporate all of this and to try and avoid these issues later. What we also find is both the firms and the companies building these facilities want uniform guidance across the country. They don't want to say, okay, I'm building in this county, new set of regulations. That if we could have uniformity, it would make it easier from a business standpoint, a
Right.
building and design standpoint, and actually, I think a health standpoint
For
to
sure.
Yeah,
do
the health.
that. And so in many of these cases, as we started pushing UV lamps, and you can do it risk-based, meaning in the beginning, do a risk assessment. Probably the best place to put those is on the kiddie areas to begin with. And they would build this into their designs. And if a client refused to add that in, what they did was they signed something to say, we have asked this firm to take it out. Because then when they have an outbreak that's due to the fact that they didn't put it in, it's their take. So
So
again, economics drives so much. And I understand that, but people need to understand that, penny pitching at this front end is probably going to cause you some pain later.
Right.
And so let's think about how you do that, and
For sure.
make sure that people are educated. The owners are educated, and so it's not just operators, but the owners are educated in the beginning about the importance of investment in key systems, air handling, filtration,
Yes.
chemical treatment, and so on.
Monitoring and so on and so forth.
Do
Yeah, I
you
agree.
see UV ever being mandated?
Yes,
Would you like to see it mandated if you had a
absolutely. Yes,
magic
we
wand?
need it. This is all about multiple barriers. No single barrier is as effective. I mean, we just came out of a pandemic, and what were the recommendations there? They were overlapping. Think of it as a piece of Swiss cheese. You get one slice, there's holes, but if you start to put together 50,
Yeah.
then you start to remove things. And so it's putting together a system. It's a
Yeah.
systems-based approach
There you go.
to health and safety.
Yeah.
That's what we've always been recommending, but this is just, it came, a little later for the aquatic side. Because again, what they were looking at is, let's not have diving board issues, and so that changed. But let's get rid of most of these pathogens. But things have, things change. So how does an industry adapt over time? That's
Right.
where we're in that process of upgrading more towards the drinking water side, which again is multi-barrier. It's old technology, much of it, but you can layer on new technology on top of it.
Exactly. Maybe Scott, if there's room for a few questions, where like I think we could continue talking for a few more hours, but I don't think that
I'm
that would
so
work
glad.
for.
I'm never at a shortage for things about
Wow, no,
water,
this
I
is so
gotta say.
interesting. Like we'll have you on again, Michael, if you enjoy it. I think
Yeah.
we'll would love to have
Uh,
a
I'm,
second.
I don't have anything uploaded as yet. Daniel, can you open that up
I
so I can
think
see
there's
that?
some questions there. So
Yeah.
one of the questions here, Scott, in the chat I see is, what was
I,
your
I'm,
job like? I guess, Scott. I don't know whether you see that. You see that?
I'm not seeing it. No.
Okay, so the
Go ahead.
question is, what was your job like as the associate director for healthy water at the CDC?
I had the best job I could ever imagine having. I loved my job because I felt I made a difference. And so I worked on a number of different things, foodborne illness, waterborne illness, fungal diseases. Did a lot of, as CDC expanded post 9/11, there were more and more large events that required people to be involved. And so no single group at CDC could handle all of it. And so I have, starting with anthrax and SARS and H1N1, Ebola, Zika, COVID, and so on. Those were always, it makes you feel like you've done something, you've accomplished something.
Right.
But, and again, as I tell people working for a government agency coming to CDC, if you're expecting things to change overnight, this is not the place for you.
It's a very
Um,
slow moving ship.
it's slow moving. What I've always said again is, thank goodness I don't. I told my EPA colleagues, thank goodness I don't work for a regulatory agency like Food and Drug or Environmental Protection, because that's even
Right.
slower because it's
Right.
regulatory. CDC is not, and
Right.
so we could make recommendations without going through a regulatory process. But there's a level of frustration with things, and so I said we had our first, waterborne recreational water illness prevention workshop in 2005. It took till 2014 to actually launch the first edition. That's about patience and perseverance and that sort of thing. But but I thought it was pretty good for its time, and it's getting better with each round. And so I public health is a job where if you go home and you don't feel what impact you have, something's wrong. Because
Right.
I never felt like that. I feel like I had impact and I left things behind, and that we made a difference. And yeah, it was fantastic. So public health, lots of jobs open,
Yeah.
county, local, state and federal level. It's really a rewarding career.
And not easy, right? Like you are obviously a subject matter expert. I know for our provincial public health inspectors who are listening, it's not an easy task because they're tasked with lots of different applications, whether it's a restaurant or a pool. And so there's a lot of subject matter expertise that, they don't get handed that. So they also have a real challenge, I guess, or an opportunity that, there's learning that all of those
It,
local inspectors have to do too.
exactly. It is always a learning curve. If you're
Right.
not learning something new regularly, you probably aren't pushing yourself enough. I think, and again, from a government standpoint, government is bureaucracy.
Right.
Frustration with leadership is the norm because they don't want to move too fast. And, whether we like it or not, public health is political. um, you know, my boss at CDC was technically the president.
Right.
CDC is in the executive branch. It answers to the president.
Right.
And it's funded by another group, Congress, who changes their mind every 15 seconds.
Yes,
And
I
so,
can imagine.
from a funding and longevity sustainability standpoint, that's a very challenging thing. So when I hear people say, run it like a business, well, we would have to get rid of our mode of government to do
Right.
that, because you can't run Congress, the president, and the courts like a business. It just, that's a very naive thing to say, because it just doesn't work like that.
No.
And so it is a
Consultative.
wonderful career that, what can I say? I think that answers it.
I have another question here, and I think we may have kind of talked about it, but I'll bring it up anyway. Somebody was kind enough to add it. If the cost effectiveness of building a pool property, if the cost effectiveness of building a pool properly from the start is the way to go, why don't most pools facilities do this? Is it ignorance factors? We really kind of had a discussion on that. However,
I mean, I think it's a combination. Economics is a huge driver, because it's like my group said I can spend 80 million, not 81.5, but 80. So I'm going to cut certain things out. The other is lack of knowledge about this. And frankly, it's very challenging to gather data to, over, multiple years to show cost effectiveness of things. You got to have somebody who's going to do that. And we're not sure who that is. So some of the companies have done it, but I think it's a real challenge. Right. To have we would love to have all the data showing that, but there aren't a lot of data out there kind of underscoring that for people. So it's about education and getting them to understand, the low cost bid may not be the best way to go.
What?
Yeah, I know. For those in government, you have to deal with that.
Yeah, I came from government. I know the deal. I have another question I'm going to ask you. So your mantra is communication and education. I think that's, you live and breathe that. And I love that you have passion with aquatics. You can feel it oozing from your pores. Yes. As we speak. Is there anything else that you would like to share with our listeners as we get to the end of our time?
The hardest thing to do is behavioral change. I think we can work on engineering changes, and codes can help with that. Operator training, and that codes can actually require it and move people forward. Changing behavior of our swimmers and consumers is the hardest job, whatever area you talk about. But it doesn't mean don't do it. Get people to understand. When I first started talking about this, television interviews, Good Morning America, all those big shows, they would refuse to let me use the word diarrhea. And finally, I just got fed up and I said, then I'm not going to come on, because people won't understand. Let's not use code where it's like a stomach bug or I'm feeling a little, let's tell it like it is, because it's about speaking to young parents of young kids, in my mind, is that if they're ill with diarrhea, they don't go swimming. Find another activity. There is no tourniquet-based containment system to encase children so they can't contaminate the water. Despite what people think about, these waterproof diapers and swim pants and all that, they're not a tourniquet. Water goes in, it comes out, and so does everything else. And so, again, what we want is those ill children to stay at home and find another activity when they're ill. Sure. Adults too, but those sorts of things. Urinating in the pool, people have used it as a joke. Olympic swimmers joking about how they do it all the time. because they can't get out during swim practice and all that sort of thing. I mean, I do understand it, but then you had one of the worst air quality issues that impacted the qualifying events for the Olympics because of air quality, and that's about urine. And so getting the swimmers and the coaches to understand that this is actually what's contributing to your lower performance standards, those sorts of things, if you're going to the pool, and we just had to do this with my 3-year-old grandchild. She got otitis externa. My wife's a big swimmer, took her to the pool. So now we've got her used to putting, some ear drops in her ear so it clears the water out. And, so that you prevent these things. So it's about prevention, educating them about illness and the way that they use the pool and what gets dumped and contaminated into it, I think is really critical that we move forward and continue to educate people. And so the reason I brought up that about I couldn't say diarrhea, that's not an issue anymore. The public does know that swimming pools are associated with illness. Perhaps they blame them too much now. They've swung the other way, but we need them to actually take action, not just blame people for something, but take action before an outbreak or whatever event has occurred.
Yes. I think we have to, as much as I would love to chat to you for another 2 hours, I think we need to, first of all, thank you. And thanks so much for your time. And we want to thank our audience for joining us and facilitating, helping us and facilitate this conversation. You can re-listen to this episode by subscribing to our YouTube channel or connecting on Apple Podcast or Spotify. And if you have any questions about the this topic or future, you can email us at mywatertalks@sunecotech.com. From Els, myself, thank you all for joining us today. And have a wonderful.
Thanks, Els. Thanks, Scott.
Thanks, Scott. Bye, guys.
Bye-bye.
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 You're still